Here we are with Unit 5, Lesson 14. We're going to apply some more principles of finding cylinder dimensions, and we're going to specifically use the formula for the volume of a cylinder. Before we get started, here's a cylinder with an unknown height. What is a possible volume for this cylinder if the diameter is 8 centimeters? And explain your reasoning. Well, we really have a lot of different ways we can go with this one, because there's a lot of possible volumes that there can be with this. If we are going to go somewhat to scale, assuming that there is somewhat of a scale here, I see this measurement is approximately 4 centimeters, and so we can look at this and say that the scale of 1 centimeter is equal to actually 2 units. So we have 8 units, and so the center of that would be approximately right here. We know that our radius would equal 4. So how does that compare to our height? Assuming, like what I said, this is following some kind of a scale, it appears that we have 3 centimeters in height here. So I'm going to go with a height and say that let's let h equal 6. And when I have those possibilities, or when I have a measurement, I can actually find the volume. In this case, though, if I want to find the possible volume for the cylinder, I would just be left with guessing. The actual volume cannot be determined. There's not enough information. Because there's not enough information, what we have to have here is we have to have at least one of 3 pieces of information. I need to have 2 of the 3. I either need to have the radius or diameter. So I need to have something to help me with the base. I need to have the height, or I need to have the total volume. I have to have at least 2 of those 3 to be able to determine the third one. And in this case, there's a lot of possibilities, but like I said, without knowing if it's exactly to scale, it really doesn't help me. I can make an estimate, and I can figure out that possibility of an estimate, but without having 2 of these 3 items, I really can't find the exact volume with this. When we look at this next one down here, what's the dimension? We're actually given 2 things. We're given the volume of a cylinder with the radius r, given as the formula here. So remember, this is our bread and butter right here. This is our main thing we need to remember, is our formula for the volume of a cylinder. In this cylinder, the radius is 5 units, and the volume of the cylinder with a radius of 5 units is 50 times pi cubic units. This statement is true. So meaning that this is actually the statement that is true. This is the given volume for the given cylinder. So what does this height of the cylinder have to be? Explain how you know. Well, like I said just a moment ago, if we know what the total volume is, and we know what the radius is, we have 2 of the 3 things that we have to know. And so when I set this equation out here, 50 times pi is equal to 5 to the second power times pi times the height. I have enough information to solve for h. So that's what we're really looking for. They're telling us to solve for h, meaning I want to get h all by itself. And I can do that by using a little bit of properties of equality. So the first thing I want to look at is to simplify. 5 to the second power is 25 times pi. And I'm going to just do something to help myself a little bit. I'm going to separate these 2 values, actually these 3 values, and just separate the height all by itself, just so that I can see this a little more. I need to divide out the 25 times pi. The reason I can divide out both of them together is because this is all together, all 3 of these is a product, meaning there's only multiplication. And so if I divide those pieces out, I can divide by 25 times pi. And there's 2 values here that I can do with this. I could do it separately. That wouldn't be a problem. But the thing that I know is this: pi divided by pi, that's the same number divided by itself, is 1. And so that brings us down to where we're getting actually 50 divided by 25 times 1. And I know 50 divided by 25 is 2. So technically, if I really wanted to get technical, this is 2 times 1. But there's not much of a point in me writing the 1 because of the identity property that says 2 times 1 is equal to 2. And so I could say that h, the height of this cylinder is 2. I could go back and verify that, and I could say 25 times the height of 2 is equal to 50, and then 50 times pi is the given volume. So I wouldn't want to actually leave it with 2. I would want to say 2 units because I need to label those lengths. Another example here, what if I have a cylinder that has a radius, an unknown radius, excuse me, but it has a height of 4 units and the 36 cubic units are given? Well, I can really start to work with the same type of thing. Let's look at this and let's think I have 36 times pi is equal to, my goal is to get radius by itself. So if I have radius squared, I don't like that there's pi times 4, so I'm going to go ahead and flip that around to 4 times pi. No big deal there. And what I want to do with this first is I want to divide out 4 times pi from the term on the right, or from the expression on the right. We'll divide out 4 times pi from the expression on the left, and we'll get with that 9. Because again, 36 divided by 4 is 9, pi divided by pi is 1, 9 times 1 is 9, and that leaves us with the radius squared. By understanding that the radius squared is going to be a number of something times 1, 2 times, that means radius times radius. I know, again, that might be a little bit odd, but we're going to get to that in the next couple of units. What I'm looking for is one single number that can be multiplied by itself to give me 9. To find this and to get r by itself, I need to take the square root of this value. And likewise with property of equality, take the square root of the left side and I get 3. So we would have to say the radius must be 3 units. Explain how I know. Solving for r in the given formula or the given equation. And then I can just verify that by substituting back in. 36 times pi is equal to 3 squared times 4 times pi. And I get, whoops, I should do that following the exact order that was given, times pi times 4. And I know that that's 36 times pi is equal to 9 times 4 times pi. So that gives me 36 times pi. All right. Next part of this is more with cylinders with unknown dimensions. What we have is a whole table that we're going to use on the next page that's going to talk about this entire cylinder. And with this entire cylinder, what we're looking for is, notice that we do have a height, we do have a radius, we do have a diameter, and together we have enough information to be able to figure out the volume. So remember, to figure out one of the 3 things, we have to have 2 of the 3 to be able to determine the unknown side. And so within this table, what we have here is we have a bunch of information that we need to be able to work through using the formula for the volume of a cylinder. And so with that cylinder, what we see with the first one is we have a given radius and a given height. And with that given radius, it's pretty easy to find the diameter. We know that it's double that size, so it would be 6. I think we could probably work down this column first as much as we can, the diameter and the radius. The next one, 12, the radius must be 6. Looks like we don't have that one yet. 8 for a diameter, 4 for a radius, don't have the next one. 10 for a radius, 20 for a diameter, 20 for a diameter, 10 for a radius, and the last one appears to be unknown. But what we can actually look at is over here to the right side. There's a lot of other information we'll go through here in a second. Remember, to find the area of the base means that we need to find the area of a circle. So in this case, the area is pi times the radius squared. And so we're going to take the area is going to be equal to pi times 3 to the second power. which would give us an area of 9 times pi. And then we simply define the volume. We simply take this value of the base, the area of the base, and we multiply it by 5 to get 45 times pi. All right, cool. So the next step where we're after, I suppose what I can do over here is I'll show how that sets up. That ends up being pi times 3 to the second power times 5. For the next one, what we're given is we're given the total volume, 108 times pi is equal to pi times the radius of 6 to the second power times the height. And since I don't know the height this time, I actually need to calculate just a little bit of work. I know that 6 to the second power is 36, so I'm going to take 108 times pi and divide by 36. I find that that's 3. So our height would be equal to 3 units. And I can set this up just to verify that the area is equal to pi times the radius of 6 squared, meaning that the area is equal to 36 times pi. And I just want to double check that 36 times 3 is definitely 108, and that's correct. The next one's just a little trickier. We're given the height instead of any kind of radius and diameter, but if I can find the radius, I can find the diameter. So in this case, r is going to be the unknown. I'm going to start with 99 times pi, which is the total volume. That will be equal to the radius squared times pi times the height of 11. And so with that in mind, I'm still taking the product of 11 and pi. I can divide that out on both sides. Pi divided by pi is 1. 99 divided by 11 is 9. And so I'm left with 9 is equal to r squared. It looks a lot like we did on a previous problem. We take the square root of r and the square root of 9, and we see that r is equal to 3, which means our diameter must be equal to 6. Let's just double check. Area is equal to pi times the radius squared, so area is equal to 9 times pi, and 9 times 11 is 99, so I know that I'm good there. A few more here. Let's go ahead and just do this next one more example like that one. Well, never mind, we haven't found this one with the height. We'll do this one first. If we have, again, the setup, well, I need a little more room. We have the setup right here to where the total volume is 16 times pi is equal to the radius, or pi times the radius of 4 squared times the height. Again, height is unknown. 4 times 4 is 16, so we're dividing by 16 pi. And that leaves us with 16 pi divided by 16 pi, which we know is 1. So our height is 1. Let's just double check this. Area is equal to pi times the radius of 4 squared. Area is equal to 16 times pi. 16 times 1 is 16. We're awesome there. Okay, I think we can go ahead and just go with the rest of this. I think you can do pretty well with those ones. Finish up these next couple of them on your own. Notice right here that we no longer have the pi symbol. That means that we have approximated pi has been approximated to 3/1400ths. So we can go ahead and approximate that. This last one could get a little tricky, but I think it's pretty easy if we start looking at just what's given right here. We see that the total volume is equal to pi times b times a to the second power. What that tells me is that b is the height right here. That leaves a as the radius. And so I can easily put radius of a right here. And then the diameter is twice as big as a. And so our area would have to be equal to pi times the radius squared, which would mean area is equal to pi times a squared. And then we get the exact same thing over here. We have pi times a squared times b, and we see all those in the same order. So the key thing from today's lesson is that we can find the volume. We need three different things to find the volume. And all we need out of those three different things is really two of the three to be able to find a third unknown. So in this lesson, we learned earlier, or we reviewed earlier, that the formula for a volume is the pi times radius squared times the height. We say that the volume depends on the radius and the height. And if we know the radius and the height, we can find the volume. So the same must be true that if we know the volume and the height, then we can find the radius, or if we know the volume and the radius, we can find the height. Nice example is given here where we have a total volume of 500 times pi cubic centimeters with a radius of 5, but we don't know the height. So we substitute pieces that we know for it in, divide by the given values to be able to find out the unknown variable. If we were to imagine a different cylinder with different values given where they give us the height but not the radius, we could go through the same process with the properties of equality to divide out the pieces that are given to us so we can find the one that's unknown. So that's it for today. Let me know if there's anything that you have questions about or that I can do for you. Good luck on the homework.